Okay, this is cycle 2, week 17 science. We have 2 science experiments this week. The first one is number 174 in the Van Cleve's science experiment book. The next one is number 177. This first one, 174, is called energy change. And so what you guys need are, I will bring some cups that have already been cut out and rulers that have the little grooves in the center and a marble. And then I'll bring a pencil, a book, I don't know, a pencil for sure, and then I'm not sure what the second object will be, but it will be wider, deeper than a pencil is. And I'll show you why in just a second. We're going to do these experiments. So I'm going to move this down here so you can see what is going on. But what I'm going to do is I'm going to take the ruler and I'm going to place the edge of the ruler against the back of the cup on the inside. So it just slides right through that little opening. Make sure the groove part is up. And then I'm going to prop the other end of the pencil up prop the other end of the ruler up with the pencil. And then, let me see, I'm going to scoot this back just a little bit. And then what we're going to do is we're going to place the marble in the edge of at the edge of the ruler in the groove. We're going to let it roll down. And I don't think I've said this yet as we've been doing these videos, but remember to help the kids, prompt them through the scientific experiment. Look at the materials. What do they think is going to happen? What do they expect to see? Write down those hypotheses, that kind of thing. Help them. Make sure that you're encouraging them to ask lots and lots of questions. So anyway, we're going to set this marble down here in the groove. We're going to let it roll. And when it gets to the edge of the cup, it moves the cup. Then we're going to move the pencil, and I'm just going to use my foundations guide and prop the ruler up. Now you can see how much taller the foundations guide is than the pencil was. We're going to prop it up with the foundations guide, do the exact same thing. Put the cup where it's touching the edge of the ruler, set the marble in the groove, and then let it go. And you see the cup moves a whole lot farther when the ruler is propped up on top of the book than it did when it was propped up on top of the ruler. So we've already kind of been talking a little bit about gravity. We've been talking about an object rolling around its center of gravity. We've been talking about the incline, so like we did with the table and the books underneath it. Now we've got the experiment where we're looking at the two variables, or the one variable, are the two different heights from which the marble started. So we're going to talk about concepts like rest. An object at rest tends to stay at rest. We're going to talk about the potential energy that an object has while it is at rest. So when my marble was sitting at the top of the ruler, while it was propped up on top of the pencil, it did not have as much potential energy as it did when it was propped up on top of the book. The higher an object is above the ground, or in this case the table, the more potential energy it has. So my marble sitting on top of the pencil had a lower potential energy than it did sitting propped up on top of my foundations guide. As gravity does its work, and it starts to exert force on the marble begins to roll down the ruler, and now my potential energy is converted into movement or kinetic energy. So because I had more potential energy, that energy was transferred to the marble, then when the marble hits the cup, the more potential energy converted to more actual kinetic energy, and it moved the cup further. So that's kind of the explanation of why the cup moves more when it's sitting on a higher incline. In week 19, we're going to memorize the first law of thermodynamics, which talks about energy cannot be created, it can only be transferred, which is another good explanation or another good talking point when you're talking about potential energy. I had to pick the marble up higher to set it on top of the ruler when it was on top of the foundations guide. Then I had to pick the ruler up to set it on top of the ruler when it was on top of the pencil. So the energy that I transferred from myself to the marble was higher when it was placed on top of the foundations guide. So that gave it a higher potential energy once it actually began to exert energy, which it was able to do when it was converted to kinetic energy by gravity as it's rolling down the ruler. So those are some good talking points and good explanations for inertia and for potential and kinetic energy. And then also, if you'd like to bring in that law of thermodynamics, that would be fantastic. It's also really amazing when you think about the fact that God has created our environment to where we can't just create energy. We are constantly relying on Him. If the sun were to quit, we would have no energy. We would die. But Scripture tells us that everything is held up by His right hand and that we can trust Him. So that's another maybe good talking point as you're talking with your students, especially your older ones, about the creation of energy and the transfer of energy. Just fun things to think about. The second experiment, number 177, is called SNAP. And so for this one, the instructions say a 4x10 strip of paper, so I'll have a few of these cut for you guys. And then it also says a full unopened soda can. And we don't really drink soda in our house, but the Super Bowl is almost here, so lots of queso is going to be made. And so I have a bajillion cans of Rotel. So I'm going to use a can of Rotel instead of a can of soda. And what you're going to do is you're just going to lay the piece of paper, the strip of paper, down on the table and then set the can on the end of it. And the idea, or the experiment, says to kind of push the paper towards the can and then pull it as quickly as you can. And what should happen is I should be able to pull the paper right out from underneath the can, and the can, if it moves, doesn't move very far at all. And you can see. So the idea that we have going on here is resistance and inertia. We talked about inertia when we did the plate. We talked about inertia a little bit when we did the balancing of the ruler on the pencil or the foundations guide. But here you can really, really see this. What is happening is that the resistance, the inertia, the resistance to change of my can is higher than or stronger than the force of the paper that is underneath it. So a stronger force is necessary to move my can. Nicole Liam on her upload for this week took this a step further, and I think this is really awesome, especially for the older kids. But she introduces the formula for force. Force equals mass times acceleration. And she asks the question, what would need to change in order to get my can to actually move? And so then she walks through the formula and she illustrates how, I'm going to bring this back down here. She illustrates how when I apply a high acceleration to pulling the paper out from underneath the can, that means, because force is mass times acceleration, that means I need a stronger force to be able to move the can. But when I slow the acceleration down, if I, instead of pulling super fast, if I accelerate more slowly, then there's not as much force that is needed to move my can, and I should be able to move it relatively easy. So I'm just going to pull it slowly, and look at that. There goes my can. So this is, not necessarily something, it wasn't in the write-up in Van Cleve, but it's something that you definitely could introduce and talk about, even with the younger kiddos, if they start asking questions, or if you want to prompt them with questions. How could we get the can to move? And then you can start planting those seeds of why and how our forces of mass and acceleration and inertia, we can start planting those seeds and talking about those ideas, even with the little bitties. So that is Cycle 2, Week 17 Science.